In this tutorial, we're gonna focus on factorizing polynomial functions and factorizing them completely, of course. But the approach really that we're gonna use is the factor method, where we first have to find the rational root theorem. Using the rational root theorem, we find a factor. We try to test. In fact, we try to test that maybe is that root a factor, and if we find that it is a factor, then we use that in synthetic division, then find what be able to factorize. Then we can then factorize the other part, which will be a quadratic function. So I might be talking something that's arbitrary. Let me just go straight into it. And we have this problem, question 1, and it says f of x is equal to 2x cubed plus 15x squared plus 6x minus 7. So this is what we have. So now what do we do here? So according to the rational root theorem, what we have to do is looking at this value here at the end, this one here. Okay, let me just write. So this value here at the end, this value at the end, and considering this value here. So these are the two values that will be cardinal in this root theorem. So I'll say it as P over what? P over Q, where my P is this value, the constant, always the constant that is there, and the constant of the leading coefficient here, or the coefficient of the leading variable, I mean, that is going to be my Q. So now what you write down is you have to write plus minus the factors of what? Of the P, and divided by plus minus the factors of what? Of Q. So you look at the factors of -7, so plus minus those. So you'll be like plus minus 1, and you have what? Plus minus what? 7. Those will be the factors. Then down there, what will you have? You have plus minus 1, and you have plus minus what? Minus 2. So this is what you get. So now these here can give you a possible what? A possible root. You not know until you test the root by plugging in the value here where x is. And if this gives you 0, then that value which you plugged in is the what? Is a root of what? Of this polynomial function, and which means you can find a linear factor for it. So now, how do we get to that point? So this would mean the possible outcomes which we can have here. Of course, that means you'd have plus minus 1. That's of course when you're dividing by this just by 1. Dividing there, let's say you're dividing by 1, -1, you'd have plus minus 7. The other ones would include, if the 2 divides into the 1s there, you have that with plus minus half. Then when the 2 divides into the 7, that would be what? Plus minus 7 over what? Over 2. So these are your possible values that you can try to test by plugging into the oasis. And if it does not give you 0, then you try another one until you get a value that will give you 0, and that there is gonna be what? It's gonna be a factor. So usually the first ones can give you what? A factor. So you start with your 1 here, plus minus 1, just try, and you see if it's going to give you what? It's going to give you 0 there. If it doesn't, try the next one. It's usually, that's what I've said, but it's not always. So you say f there, so f is going to be equal to, so you have 2, then let's replace. So I'm replacing what? 1. Let me use 1 first. So I have 1 there. So I'm going to use a different color here. We use yellow, all of it. So I have 2, then I have 1 cubed there, plus, what do I have? A 15, 1 squared, plus 6, 1, minus what? 7. So there, this gives me what? This gives me 2, that gives me plus 15, then I get a plus 6, then a minus what? 7. And when I add this, what do I get? That's -1. And this gives me 16. So this gives me 16, but 16 is not equal to 0. So what does this mean? This means that 1 is not a what? Is not a root of this what? Of this polynomial. So it's not that, but I can still try another one. Let me try. So I move on to trying -1 now. Since I've tried 1 has failed, I'll use what? -1. So we're saying x equal to what? -1. So I have 2 -1 cubed plus 15 -1 squared, then plus 6 -1, then you have -7. So this gives you what? This here will give you -2, since this is you're raising to an odd power, so the negative sign will still be there. So this will be -2. This gives me a positive 15. Then what do the rest give me? I'll get a -6 there, -7. I add these two here. So when I add these two, what do I get? -7 and -1. This gives me -13 by plus that there. This will give me -15 plus a 15. And this gives me 0. So it means something. So that means that 1 is actually what? A root of this what? Of this polynomial. So if 1 is a root, so I can get rid of this here and also this here. Let me remain with that equation there. So we found out that actually x equal to -1, I mean -1 is what? Is a root of this equation. So meaning, what's the linear factor? The linear factor is going to be x plus what? Plus 1. So I factored out, this is the first part already, I know, factored out like this. So what does this have to tell me? I have to divide. So I use synthetic division. I can use long division, but synthetic division will be easier here and quicker, of course. So use synthetic division with a factor, of course, which is x plus 1. Then after I use the synthetic division, I get a quadratic function, which I then later can factorize as well. So how will I do this? So to synthetic division, you have your factor x plus 1. So what you always put here, your value, you're dividing the value of what? Of x is what you're using here, which we found to be -1. So you put your -1 there. Then you get the coefficients of what? Of these variables, including the constant, and you place them there, place them nicely. Of course, if there's a part that was missing, so here we have x cubed, x squared, x, and the constant, so they are all there. But in a case maybe where we had x cubed, then we see that the next one maybe that followed was x squared. Just x, you would put a place value for the x squared, which is going to be 0. So you'd put your value as 2, 0, and 1, and 6, like that. Okay, since now we have all of them for us, you just put them the way they are. That's going to be 2. We have for the x squared, which is 15, and for x is just 6. Then I have what? -7. So just like that. And then here, what do I do? So you always drop this one first. The first one, you just drop it the way it is. So you get 2 here. Then you multiply this 2, multiplied by this number, which is here, which is -1. Multiply by that -1 to get your next value here. And that will give you -2. So it's 2 by -1 gives me -2. Then you add your 15 plus your what? Plus your -2. And that you just get 13. 13 multiplied by -1, that gives me -what? 13. I can add these 2 here, I'll get a -7. -7 multiplied by -1, that gives me a +7. And this here gives me what? 0 when I add the 2. So, which means that I have a remainder. The last value which you always have here when we're dealing with synthetic division, this is your remainder. This tells us that our remainder is what? Is 0. And this what we have here is actually now our what? Our quadratic function. So now at this stage, what we just have is this. So I'm gonna write it down here. So what we just have is, so remember we've already factored out the first part, which we found as x plus 1. So now what we factored out, this which we have is gonna be 2. So you start with the degree. So we were moving from degree 3 here to be 2, where we're going to degree 2, which is x squared. Then this there next follows will be plus 13x, then of course minus what? 7, like this. But now what do I have to do? I have to complete the square here. I can use whatever method, of course, either by completing the square or by whatever method of course I can use to be able to find those factors. If I want, I can use the factor method where I look at these here, where I say I can multiply this. My product is gonna be -7 and 2 gives me -14, and my sum there is what is 13. Then I try to look for factors here. What factors, if I add, they give me negative. If I add, they give me 13. If I multiply, they give me what? -14. And that's just easily seen. That's -1 and what? -1 and 14. When I multiply these, I get -14. When I add, I get 13. So this is how it simplifies. Then I can write those as what? Those there are gonna be my what? My factors. And of course, I can what? Factorize by grouping here. So I have x plus 1. Then I have 2x squared. Then what am I gonna have here? I can write that as negative what? Negative x, then plus 14x minus 7. Then by grouping there, I'm gonna have group these two. What's the common factor there? It's x. X is a common factor. Then here I remain with what? That means I remain with 2x minus 1. Then there I have a plus. What's the factor that I'm gonna use? 7, of course. This is gonna be 7. So I have 7 here. Then this here leaves me with 2x, and there leaves me with -1. And of course, I choose one of them here. Okay, can you erase this part? Can you erase all this here? So there, what do I then remain with? I then remain with x plus 1. Then I choose one of these here since they're the same. So that would be 2x minus 1. Then I get my x plus my 7 there, x plus what? 7. So I have factored or factorized this what? This polynomial function like that. So that's how you do it. Easy, I guess, if you follow the steps that are given there. All right, next we just do the last question. And yeah, so we will choose to do question D. In yeah, do question D. Then of course the rest can be solved by you guys. Anyone else want to try them? So you have the P being equal to 2x plus this gives me what? That's plus 5x squared minus x cubed minus 24. Just get the negative signs there. So really you can arrange this in a very nice way. So what's going to be that nice way? Let me say I factor out a negative here. Let's say I write it as x cubed, and this here be written as -5x squared. Then I'll just have -2x, then I have a plus 24 there. So I write it in that way. Then using the rational root theorem, I can then find for my quotient, this here which is inside, I'm gonna find a root which I'm gonna test. Of course, I see that there's 24 here, so meaning it's the factors of 24. So that's plus minus 1, plus minus 2, plus minus 3, plus minus 6, 4, plus minus 6. Then I have a plus minus 8 and plus minus 12, also plus minus 24. And all this is dividing, of course, by plus minus what? Plus minus 1. And of course, when you divide, you still get these factors here on top. And you just gotta check. You start picking those out, and you see which one is what, which one is going to give you. So all right, I randomly want to choose 3. I want to choose x. I start with 3 with this one, because on the other one we started with the first one. So I want to see if maybe try with another one. So yeah, so what I have here inside, so it's what I have inside here is what I'm testing. So in short, my function, I'll write it in terms of q now. Say 3. So what is q? Q is what's here inside. So what is inside, if you can see, 3. So I said 3 here is what I'm going to try. Minus 5, 3 squared, minus 2, 3 plus 24. And that gives me 27 here. That gives me 9 multiplied by what gives me 45. Then I have that multiplied, that gives me 6. And I have a plus 24. So what does this give me? So this here is gonna give me a 0. So when I add all this here, this has to give what gives me 0. Because so on there I have 27 plus this here gives me, does this give me here? This gives me 11, 1, and that gives me 4, 5, 51, and which is gonna be negative. This is gonna be 51 minus 51, which is gonna give me 0. So 3 is a what? Is a factor there. So x equal to 3 is a factor. It's a root, and the root of this polynomial, so I can keep that. X equal to what? To 3. So which means the factor is going to be x minus what? Minus 3. That's the factor there, the first one which we're going to get. And next step is we use synthetic division in order to what? To come up with the other what? Factors of this polynomial, in order to come up with the factors of this polynomial here. So what am I going to get? So let me not forget that I factored out this, that I said a negative there, then I said x cubed, then I said negative 5x squared, then that gave me negative 2x, then plus 24. So I should not forget about this. So, but then synthetic division here, really, so I have a 3 there is what I'm dividing by. Then I get the coefficients, which is going to be 2, okay, let me not start with 2. 2, 2, 2, 2 is not the first one. Start with the one, the degree of what? The degree there which we're gonna have here when we look, we have 1. Next one is negative 5. I don't know why I started with that one, but yeah, negative 5, negative 2, and you have a what? A 24. And here there's 0, so 0, 1 plus 0 just gives you 1. 1 multiplied by 3 gives you 3. 3 plus negative 5 gives you negative 2. Negative 2 multiplied by 3 gives you negative 6. Negative 6 plus negative 2 gives you negative 8. Negative 8 multiplied by 3 gives you negative 24, and this gives you 0. So the remainder there 0. So meaning this is a polynomial of degree 2, of course, a quadratic, which is x squared minus 2x minus what? 8, like this. So in short, what you have is the first factor there, x minus this, then you have x squared minus 2x minus what? X. So that's what you get. Now you can then easily factor this out. So you look for two numbers. So we're saying two numbers here where we multiply, in short, your product. Where am I going to write this? Your product there is going to be negative 8, and your sum is what? Negative 2. So when you add, you get negative 2, and when you multiply, you should get what? Negative 8. So that's what, those are the factors of, that's 4, negative 4, of course, and 2. Because when we add this, we get negative 2, multiply, we get that. Yeah, so this just gonna give us, so you do all the factors. I know you know how to do that. So this just gives you x minus 4. Then you have what? You have x plus 2, like that. And remember that negative sign which is there, which we had factored out. So this means that this is gonna just factorize to p of x being 2, there's a negative sign there, and that negative sign multiplies all throughout with this here, so that it's gonna be like this, and x plus what plus 2, and this is gonna be how you factorize this completely. That's how you factorize polynomials completely, by using synthetic division. Well, if you're new, remember to subscribe for more videos, and remember to share and like. I'll see you in the next video.